Hello everyone, I am Soumyashree Senapati, Assistant Professor, Vedang Institute of Technology. We have already discussed about strain calculation in case of thin cylinder, but we have not done any numericals. So, in this numerical, we will know how to put those formulas in case of numerical. Okay, so first, going to this numerical, we need to understand what is the question asking about. So, first, here it is given to calculate the change in diameter, change in length and change in volume. So, we already know the formulas. First of all, we need to write those formulas. Change in diameter, in case of what? We know that change in diameter is del D. So, right, then for change in length. Next is your change in volume. I have written the formulas. So, to get these formulas, what we need that are in this question. So, first written is take a thin cylinder about what? 100 centimeter diameter. So, we before these formulas we need to write what are the given data. Okay. So, in given data, we have our diameter as small d taken as what? 100 centimeter, and next given is 1 centimeter thick. As we are learning about what? Our thin cylinder. So, here our thin cylinder is like this. So, we have the what? Diameter. This to this length is 100 centimeter. And next, what is given? Thickness of the cylinder. Okay. So, this to this is our what? 1 centimeter. Right. So, next 5 meter long. So, length is given. This to this is what? 5 centimeter. Next, what we need? To calculate this sigma C, we need what? PD upon 2T. So, we have D and T, but what is P? Here, our internal pressure is given, that is 5 Newton per mm square. So, we can write what? 5 Newton per mm square. And we also need to calculation of strain. How to calculate strain? Our stress upon elastic constant, that is Young's modulus. So, we will calculate sigma C, and here we have our E, Young's modulus, as 2 into 10 to the power 5. Okay. Next what? Mu is our Poisson's ratio. Right. So, we have D, T, P, L and E and mu. L is our 5 centimeter. Okay. So, now we don't need this diagram. Right. Okay. So, we can see here E and P are in Newton per mm square. The unit is Newton per mm square. Before solving any numerical in case of SOM or in civil engineering, you need to focus on unit. Okay. So, here unit is in Newton per mm square, and here also. So we need to convert all the centimeters to mm. Okay, we know that 1 centimeter equals to what? 10 mm. So here it will be 1000 mm, this 10 mm, and L is our what? 50 mm. It's millimeter. Okay. So now we have all our given data and formula. We need to what? Just put these values in this formula and we'll get the answer. So to calculate first, to calculate change in diameter, we need what? We need this sigma c. So what? Sigma c is what? PD upon 2T. We can write 5 into D is our 1000, 2 into thickness is 10. So this 0 to 0 will cancel. Okay, and this will be 50. 50 into 5, what? 250. Okay, we get sigma c as 250 Newton per mm square. Right. Now what we will calculate? We will calculate our what? Del D. This. Right. How to calculate? So here we will put the formulas and we will get the value. Sigma c as sigma c, we can write sigma c multiply with D upon E into 1 minus mu upon 2. So sigma c is what? 250 into D is your what? 1000 mm upon E is what? 2 into 10 to the power 5. 1 minus 0.3 upon 2. So we will calculate this now. So we can write it as easy. Now we can cancel 1, 2, 3, 4. Right? So our del D value will be 1 minus 0.15. That is what? 0.85. Right? (1.25) multiply with 0.85. So our change in diameter will be what? 1.06 mm. Right? We got our change in diameter value. Next, what we will calculate? We will calculate our del L value. I need to calculate here only because what? The values are here. Okay. So Del L is what? We can shift this L to this area. Okay, so del L will be sigma C into L upon E 1 by 2 minus mu. We have already taken what? 1 by m in case of solving formulas, but I have already said what? 1 by m is nothing but our mu. Mu, that is Poisson's ratio. Sigma C is what? We have already get 250 into length is 5 meter. So what? We will put it 5,000, 2 into 10 to the power 5. We can write in this way also. 1 by 2 minus 0.3. So we will cancel this 3, 4. Right. We can write it as 125 upon 20. 1 by 2 is our 0.5 minus 0.3 equals to 0.2. (25) divided by 4 into 0.2. So our change in length will be what? 1.25 in mm. So this change in length are very minute. Okay. So next, to calculate change in volume, we can also put the formula for volume and directly solve, but as we have already got our what? Del L and del D, so easily we can get what? EL and EC is what? EL is our longitudinal strain, that is del L upon L, right? So we 1.25 upon 5,000 we will get EL. Del EC is our circumferential strain. So it will be 1.06 upon D is what? Diameter is 100 centimeter. That will be 1000. So okay, EL is 0.06 upon 1000. It will be 0.00106. We have our EC and EL. So we know the formula for del V by V is what? EL, that is 0.00025 plus multiply with 2, 0.00106, right? It will be 0. Sorry, it will be 2 into 0.00106. You can use scientific calculator, so it will be proper answer you will get. Zero point 00237 in what? Mm. So here we have our what? Change in diameter, change in length and change in volume. So, okay, these two formulas for change in diameter and this change in diameter and change in length is very confusing. So, how to remember this? So, in case of circumferential strains and longitudinal strain, always in case of stress calculation, what? We always know that circumferential stress is greater than longitudinal stress. So, here also in case of formulas in strain, what happens? In circumferential stress, this term is bigger than this. So, we will remember these formulas like this. Like in case of calculation of circumferential strain, so the first term is larger one, and in case of longitudinal strain, this first term is smaller one. Okay. So, in this class, we have already solved one numerical based upon our strain calculation in thin cylinder. In our next classes, we will solve lots of numericals. So, I hope you understand this numerical. Thank you so much.